Hi everyone, this is practice formative of chapter 4, question number 18. So in this question, we are given the digit of 0. So 0, and then 3, 4, 5, 6, and 7. So we have the odd digit. That is 3, 5, and 7. And then even digits, which is 4 and 6. So all in all, we have 6 numbers. Okay, 6 cards here. So now let's go to A. We have to form 4-digit odd numbers. So 1, 2, 3, 4. So in order to get the odd numbers, the last digit must fill with odd numbers. So our odd numbers, we have 3 to choose from. So 3 choices here. Okay, so 6 numbers, 1 goes in, left with 5 numbers. Now out of these 5 numbers, we have a 0 and 4 others. Okay, therefore, now we fill in the first empty slot. 0 cannot go in. 0 cannot go in, therefore we only can choose from the rest of the 4 numbers, regardless whether it is odd or even, doesn't matter. So we have 4 choices here. So once 1 already go in, so we're left with 3. And 3 plus with the 0, we have 4 numbers here for us to choose to fill in the second empty slot. So 4 choices. After 1 goes in, left with 3 choices. Okay? Therefore, the number of arrangement will be 4 times 4 times 3 times 3. Okay, so we have 4 times 3 is 12. 4 times 3 is another 12. 12 times 12 is 144. Okay, so we have 144 ways to arrange the 4-digit odd numbers. Next, 4-digit numbers that begin with an even digit. Okay, for B, 1, 2, 3, 4. Okay, any of the 4 number, but must begin with an even digit. So for even digit, we have 4 and 6. 0, we don't count. Okay, so we have 2 choices here. 2 choices here. Once we have chosen one of the number, our n will now left with 5. Therefore, all these 5 numbers can go in freely. So we're left with 5 choices. After 1 go in, left with 4 choices, and then left with 3. Therefore, all right, the number of arrangements will be 2 times 5 times 4 times 3. This one multiply, we got 12 times with the 10, 120 ways. Okay, and next, part C. Okay, for part C, 4-digit numbers with all the odd digits together. Odd digits must come together. Okay, so for part C, 1, 2, 3, and 4. Okay, let's see, we have 3 odd digits. Okay, 3 odd digits. So for odd, we have 3, 5, 7, and then the even is 4 and 6, and then the special one, 0. Okay. All right, so odd digits must come together for part C. So let's box up. Okay. Now, therefore, we have 2 scenarios. It's either like this or like this, 1, 2, 3, 4. Okay, I have to put this 2 scenario here because I will only have 6. Okay, 1, 2, 3 is here, so 3, 2, 1. So in this group, among themselves, they will permute each other. What about this empty slot? I left with 4, 6, and 0 to choose from. So 3 choices here. Okay, but if the odd numbers are all at the back, this first digit can only choose from 4 and 6. 0 can never start any number. Therefore, we have two choices here. So for the OR, we plus. So 3, 2, 1 times 3, 6 times 3, 18. And then 3, 2, 1, 6 times 2, 12. Therefore, the number of arrangement will be 18 plus 12, that is 30. Okay, there are 30 ways to arrange the numbers in such condition. All right, for part D. So for part D, we have 4-digit numbers with odd and even digits at the alternate position. So 1, 2, 3, 4. If we start with even digit, so start with even, this will be odd, this is even, this is odd. Or 1, 2, 3, 4, we start with odd, followed by even, odd, even. Okay, so for the even digits, we choose from 4 to 6. Okay, so we have only 4 and 6, so we have only two choices here. And then the even digits here, 0 also put in. So two choices here, because one of the 4 or 6 is already going in the first empty space. So we're left with 2, okay, that form the even digits. And therefore, the odd digits will be 3 choices, followed by 2 choices here. Or we start with odd digits, 3, 2, and the even digits we can choose freely from 4, 6, and 0. So 3 and 2. Therefore, the number of arrangement will be 2 times 3 times 2 times 2. 24 plus with 3 times 2 is 6, another 3 times 2 is 6, so 36. So all in all, we have 60 ways to arrange the numbers that fulfill the criteria set in D. Okay, as for part E, all right, we need to form even numbers that are greater than 50,000. So 50,000 means we have 1, 2, 3, 4, 5, 5-digit numbers, or we may also form 6-digit number, because 6-digit number is definitely greater than 50,000, because the number that we are given are 0, 4, and 6, and then 3, 5, and 7. Okay, the 0, we have to be very, very careful when we handle it, because we cannot start any number with 0. So in this case, let's look at the scenario here. We have 5-digit number. In order for us to get the even numbers, we can just put it this way. It's either it ends with 0 or 5-digit number, okay, end with either 4 or 6. So when it must end with 0, so only one choice. Okay, only one choice. If it ends with either 4 or 6, so we have two choices here. All right, and then once we're done with that, so let's look at the first part, because the first part we can only choose from 5, 6, and 7. 5, 6, and 7. So for this, we have 3 choices to go in. All right, so 2 numbers is already put into the empty slot. So we're left with 4 digits. Therefore, 4, 3, 2. Because all in all, we have 6 digits. Okay. Okay, we have a problem here as well, because I do not know whether 4 goes in or 6 goes in. So I have to fix, yeah. So if 4 goes in, therefore I have only one choice here. And for the first digit, I can just put in either 5, 6, or 7, 3 choices here. So 2 numbers is already inserted into the empty slots. We're left with 4 digits. Therefore, 4 choices, 3 choices, 2 choices. Or the third scenario is when we end the last digit with 6. So only one choice. Okay, then we look at the first digit. 6 is already put at the back. So the first digit, we can only choose from 5 or 7. So we have 2 choices here. So 2 numbers is already in. We're left with 4 numbers. So 4 choices, 3 choices, 2 choices. So this is the scenario where we have 5-digit number. When we have 6-digit number, same thing. We fix the 0. And then another one will be, since this is 6-digit numbers, any number, it can start with any number, it will definitely greater than 50,000. So we don't have to worry to fix the 4 or the 6 at the back. Okay, just put 4 and 6 here. So we have 2 choices here, whereby when we need to end with 0, only 1 choice. So 6 digits, 1 already inserted, we're left with 5. So we can just insert freely 5, 4, 3, 2, 1. Whereas when 1 already go to the back, so one of the 4 or 6 will join with the remaining 4 numbers, because we use the 4 and 6. Yeah, so the remaining 1, 2, 3, 4 plus the balance of the 1 digit from 4 or 6, we have 5. We have 5 digits. However, we cannot put 0 in the first part. In the first place, we can't put 0. Therefore, we only have 4 other digits to choose from. So we have 4 choices here. So 2 digits is already inserted. So all in all, we're left with 4 digits. So 4 choices, 3 choices, 2 choices, 1 choice. Therefore, let's find. Okay, all these are different scenario, or the word or means with plus. Okay, so we have 5 scenarios here. So for each scenario, let's find the number of ways. So 3 times 4 times 3 times 2, 72 ways. So because 3 times 3 is 9, 9 times the 8, 72. Okay, and this one, again, 3 times 3 is 9, 4 times 2 is 8, so 9 times 8, we have 72 ways. At the bottom here, we have 4 times 3, 12, 12 times 2, 24, 24 times 2, 48. Okay, and then over here, 5 times 2 is 10, 4 times 3 is 12, so we have 120. And then over here we have 4 times 4, 16, 2 times 2, 4. So we have 64, 16 times 4 is 64, 64 times 3. 64 times 3, that will be 192. So all in all, we can find number of arrangement that will be 72 plus 72 plus 48 plus 120 plus 192. Okay. Let us use the calculator to find the total. So we have 2 times of 72. We have 2 times of 72 plus 48, and then plus 120 plus 190, 192. So 504. 504 is the number of ways.